I welcome you to NEET World. So we'll be continuing our discussion on EAPCET 2025 question papers. Okay, so if you are looking for EAPCET 2025 question papers, so you just join our Telegram group where we are providing the link for joining the Telegram group in the description box. You just click on that, so it will direct you to the Telegram group and you can access all these question papers there. Okay, so now today we will be discussing the questions of this EAPCET paper. See, the first question says here, which are the following has highest mass? Okay, so they have given different compounds over here, so, and they are asking about their mass. See, 0.5 grams of oxygen they mentioned, so directly mass is mentioned for this particular substance as 0.5. Okay, so I am taking other color pen. Let me take. So it is how much? 0.5 grams is mentioned. So this is mentioned as 0.5 mole. So number of moles is given. So number of moles means weight by its molar mass, right? So number of moles are given. So molar mass of ozone is how much? O3 is the ozone now. So it will be 48 grams per mole. Okay, per mole. So given moles is 0.5, so into 48, so this gives you what? The weight of the substance. So how much you will get? So 24 grams of ozone is given. So here it is given as 3 into 10 power 22 molecules of nitrogen. So N2 is given. See, if they given 6.02 into 10 power 23, then you can say it is 28 grams of N2. Okay, so now how much they given? So they given 3 into 10 power 22. It means how much weight it is. So how can you do this? So just see how many times it is reduced. So it is reduced by 1 by 20 times. So here also our x will be how much? X will be equals to 28 by 20. So this will be your answer. So x will be how much? So 2.8 by 2. It means 1.4 grams I can say. 1.4 grams of nitrogen is given. Like this, even if you calculate for this, see 5.6 liters of SO2 means CO2 means what? So 5.6 liters means what? At STP condition, 22.4 liters means 1 mole. 1 mole of CO2, that is nothing but 44 grams, right? Now given it as 5.6 liters. So 5.6 liters means how many times it is reduced? Just look here. So it is reduced by 1 by 4 times now. So 22.4 divided by 4 gives 5.6 liter. So you here also you just divide this number by 1 by 4. Okay, so divide this 44 by 4, you will get how much? 11 grams. So 5.6 liters of CO2 means this is indicates 11 grams. Now which is having maximum mass here? It is ozone. Okay, hope it is clear now. Now I will be asking you one question. Now arrange the 4 substances. See, for this question option 2 is perfect answer as it is having 24 grams. Now I am asking you arrange this 4 option based on the increasing order of mass, highest to lowest mass. So which is having highest, which is having lowest, like that you arrange based on your understanding here. Hope it is clear. Now let us move for the next question. Yeah, so guys, here we have question from chemical bonding. Okay, so about this particular topic I have explained clearly in my class discussion of this chemical bonding, valence shell electron pair repulsion theory, as well as octet rule. So based on that you can easily solve this. See, they are asking about number of molecules in which central atom has expanded octet. So what is mean by octet first? If it is contain 8 electrons, if it contains 8 electron, you can say it is octet configuration, right? Octet. So why octet here we are saying? So in the second shell, if I consider second period or second shell, if we consider like this, so 2s and 2p we are saying now. So 2s can accommodate maximum of 2 electron and p can accommodate maximum of 6. So totally how many electrons here we have? 8 electrons now, right? Okay, so this whenever we have fully filled orbitals, so those electronic configuration are stable. Okay, so now here 8 electron containing species are what? Okay, if more than 8 are there, then we can say expanded octet. If it is less than 8, we can say incomplete octet. Now see here we have ClF3. So ClF3 means Cl. So how many valency electrons are there with the chlorine here? It will be having 7 valency electrons. Okay, like this, and around that fluorines are there. So around this fluorines are there. So now each fluorine also contains 7 valency electrons. right? Now if you observe here, the chlorine, now whenever it is making a bond with these fluorines like this, now it will be having how many electrons? See, 2 electrons, 3, 4 electrons, 5, 6, 7, 8, 9, 10. So it is having 10 electrons. So 10 electrons around the chlorine. It means it is more than the octet configuration, right? Yes. So it is more than octet means it is expanded octet. Similarly, SF6 also having expanded octet. Next, here ammonia and methane will be having octet rule configuration. Okay. So 1, 2, next SF6 and SF4 also, and then next here we have XeF4 and PCl5. So 1, 2, 3, 4, 5. So how many are there? So 5 compounds with like what, expanded octet rule configuration. So option 3 your answer. Hope it is also clear. Now let us move further. Yes. So will you try to answer this question? Yes, give a try. Just give a try for solving this question. Yes guys, I hope you are following our classes daily. We were conducting for every subject, we will be conducting 2 live sessions every day along with other videos. Okay, so this live session, one live session will be completely dedicated for solving previous year questions of JEE, NEET and EAPCET exams. Okay, and one more live session where we are covering fully important topics, like that. That session will be fully loaded with what? Only important topics that must be covered for upcoming JEE, NEET and EAPCET. Hope you are following these 2 live sessions. Okay, so for those in that important live session where we have named it as 100 days challenge for NEET and EAPCET as well as JEE exam. I hope you are following for all the subjects, chemistry, maths, physics and as well as biology, right? Now here after me again physics questionnaire session will be done by Vignesh sir. So like that every faculty will be discussing their own subject. Hope you are following all this content, right? So if you haven't followed us or if you haven't subscribed us till now, so just click on the subscribe button so that you will get daily updates from us, and also join the Telegram group where you can get daily updates from us. What are the classes and what are the free lectures we are providing, everything you will get to know from that. Okay, so now which the number of d electrons in Fe2 is not equals the number of d electrons in Fe2. Iron plus 2 compound is given, like ion is given, Fe plus 2 is given. Okay, its atomic number is 26. Okay, not equals to. So they are saying number of d electrons in Fe plus 2 is not equals to which of these. So how many we have? So 26 now. Atomic number 26 means iron should have, what is the electronic configuration? It should have 4s2. See, write this s 2 in this s orbital, 6 in this d orbital, 4s2, 3d6 like this. It is the case when you are writing for iron metal atom. Okay, here it is ion na, so plus 2 charge means remove 2 electrons. So remove 2 electrons from here so that it will be getting Fe plus 2, it means 3d6, 4s0. Okay, so this is the electronic configuration now we have. So how many unpaired electrons we have in this? So like they are asking just number of d electrons here, d6 na, that's it. So it means like you can fill it like this. If they ask even for unpaired electron also, you can answer no. Okay, they are asking for number of d electrons. See the number of p electrons in neon. So how many p electrons are we have in the neon? Yes, neon contains 2s2, see 1s2, 2s2, 2p6. Yes, so p electrons and d electrons. See the number of p electrons in neon. Okay, it is 2p6. Okay, then next here we have not equals to, this is equals to this number only. Okay, they are asking about not equal. See 6, 6 here also they are equal, they are asking not equal. See the number of s electrons in magnesium. See how many electrons are there in magnesium? 1s2, 2s2 like this, and next 2p, 6 up to here 10 over, it is number is 12. So the next 3s2 will be getting. So how many s electrons are there? S electrons 2, 4, 6. So here also it is 6. So that is also equals to 3d6 number of electrons, right? So this is also equal. They are asking about not equal. So do not choose this one. Do not choose this one. Now here you can see number of d electrons in iron. So number of d electrons in iron is how much? It is also having same now. So it is having 3d6, here also 3d6. So both of them are same. So they are now asking you not equal. So you should not choose this, because all the first three options are equal to 6 electrons which are present in this orbital, in this 3D orbital. Now number of p electrons in chlorine. So chlorine atomic number is also given, Cl17 is mentioned. Now how can you write this? So it is 1s2, 2s2, 2p6, okay, the next 3s2, okay, see 10 over 12, so 5 more we need to fill, so that will be 3p5. Okay, so like this you need to fill. Number of p electrons is how many now? So here 6 and here 5. So total 11 electrons are there. But in D how many are there? Only 6 are there. So these are not equal now. So it means you need to choose this as the answer, because they are asking about not equal, means the fourth option is perfect answer for this. Hope it is clear now, right? Now let us move further. Again there is a question from molecular orbital theory. Yes, how do you write or how do you solve this question? See, they given O2, O2 minus, O2 2 minus. So how can we answer this question? Tell me. Look here. So for O2, we know oxygen atomic number is 8. It is given as molecule O2 molecule. So 16 electrons are there. So 16 electrons means how can you fill this? So you can fill. See, for both oxygen atoms, it will be having 1s, it is also having 1s. Similarly, it is having 2s, this is also having 2s. Again 2p, again here also 2p. Like that we have now. So this 1s orbital, 2s orbital will combine to form molecular orbital like this. Sigma 1s, this is bonding, sigma star 1s, this is anti-bonding. Similarly, sigma 2s bonding, sigma star 2s, this is anti-bonding. Then next, okay, so then next here we have sigma 2px, 2pz I am writing. The next pi 2py equals to pi 2pz, pi 2px I am taking here, okay, like this. After this, respect to anti-bonding, see pi star 2px, see pi star 2px equals to pi star 2py, okay, and finally anti-bonding of this will be sigma star 2pz. Like this you need to write, okay. So now 1s orbital, 2s orbital combined, again 2p orbitals are also combined, therefore we are getting this many orbitals. See, 1s, we are getting 1s and 1s star, like bonding, anti-bonding, like this. Whenever two atomic orbitals combine, so they will give two molecular orbitals, one is bonding, another one is anti-bonding. So that is the case in this situation. Now in oxygen we have atomic number is 8, so 8 electrons are there, so molecule means 16 electrons. So fill 2 electrons in each of these orbitals, like 2 here, 2 here, so 2 here, 6 over, 7, 8, 9, 10 over, 11, 12, 13, 14 over, okay, 15, 16. So this is the case now. So now identify number of anti-bonding electrons now. How many are there? See, a star mark indicates anti-bonding orbital. So 2, 4, 5, 6. So 6 anti-bonding electrons, 6 anti-bonding electrons in what? In O2 molecule. Like that. So for O2 minus, it means you should fill one more electron here. Okay, so this is the 17th electron. O2 minus means, see, O2 means 16, O2 minus means you need to add one more electron, so that 16 plus 1 become 17. That 17th electron will enter here, so it means, so O2 minus will be having how many? So 6 plus 1, 7 electrons. So now O2 2 minus means what? So it will be having 18 electron, that one more electron goes here, so therefore O2 2 minus will be having how many electrons? 8 electrons here. So totally how many electrons totally count here? See here, 6 plus 8, 14 plus 7, how much? 14 plus 7, it is 21 electrons. Hope it is clear. Now we got option 3 as our answer here. So this is our answer right now. So I hope the concept is clear, and if you are looking more about this molecular orbital theory, so I have made almost 1 hour dedicated video on molecular orbital theory, so that will be very useful. You can watch it, okay. And if you have any queries, feel free to ask me in the chat box. I am looking into live chat, okay. So just you can type something, whatever you are wanted to know in the chat box. I will explain that, or I will address that. Yes. Then next, let us move further. Again here we have a question from conjugate acid base of ammonia are X and Y respectively. The shapes of X and Y respectively are, see, very nice question and very basic question it is. See, ammonia is given, so this is the ammonia. Okay, so ammonia when it accepts, see, ammonia is a basic Lewis base, I'm saying. So why it is Lewis base? It will accept, it will donate this pair of electrons to H plus or any other electron deficient site. Okay, so that I can say this is Lewis base and forms NH4 plus ion, ammonium ion. So now ammonium ion will be having what shape? It will be having tetrahedral shape. So how it will be tetrahedral? So at the center we have nitrogen. So here one hydrogen, here one more hydrogen above the plane and one hydrogen below the plane like this, and one more within the plane. So two hydrogens within the plane, one is above, one is below. So this is what the shape is called, tetrahedral shape. Okay, so now they are asking about the conjugate acid. See the shape of this conjugate acid, see, conjugate acid and a conjugate base. So this is conjugate acid, so having tetrahedral shape. So angle is how much? 109.28 minute, 108 degrees 28 minutes you can say. Now what about this? Conjugate acid is this one. Conjugate base means it should liberate one H plus ion, I mean one, like conjugate base means after releasing this H plus ion, so I am removing one H plus from here. See, when it accept H plus, it will form a conjugate acid. When it's release H plus, it will form a conjugate base. So it will be having like this, NH2 minus. So NH2 minus means, see, you know, water molecule now, so oxygen with two hydrogens. So how it will be? OH, it will be like this, here set of lone pair, here one more set of lone pair. Similar to this, here we have nitrogen like this. See, whenever it is ammonia, it will be having one set of lone pair. Now after releasing one H plus ion, one more set of lone pair will be there here. So it means it is also structure looks like ammonia, like water molecule only. So nitrogen at the center, okay, one hydrogen here, another hydrogen here, lone pair electrons here, lone pair electrons here. So what is the shape of this? See, it is like bent shape, right, like this. So you can say angular or bent. So it is angular or bent. Okay, so here we have tetrahedral is this one, conjugate acid, conjugate base is angular. So which is our option? So option 2 is our perfect answer for this question. Hope it is also clear now. Yes. So if you are clear with this explanation, just click on the like button so that I can confirm that you are really following the class. Yes. Then next. Now, so this question is from diboron preparation, right? So NaBH4, sodium borohydride, upon treating with iodine, so what happens? It forms B2H6 here. So A is our B2H6. What is that? B2H6. Okay, so along with that Na and H2 gas is liberated. Very important topic, diboron topic. I have discussed about this diboron in 10 minutes, less than 10 minutes. A special video is there, you can watch in the playlist. Okay, so and this diboron B2H6 upon treating with lithium hydride LiH. Okay, so LiH, the diboron is electron deficient. Now hydride ion is a nucleophile here. Okay, so that will react with this and forms lithium borohydride LiBH4 like this. Okay, so now this is the product B here and product A is our B2H6. The reaction A and B are respectively what they are? So they are B2H6 and LiBH4, lithium borohydride. Hope it is also clear, right? Yeah. Now, can you say what is the use of this lithium borohydride? Yeah, so we can use this as a reducing agent because it is a source of H minus. Okay, we will use this as a organic reagents, as a reducing reagent in organic chemistry. Okay, for reduction of some carbonyl compounds or some like for reduction purpose we can use. And one more question here I am asking. So what is the hybridization of boron in B2H6? Okay, so this is a question you will be seeing regularly in the exams. Okay, so what is the hybridization of this boron atoms in B2H6? I want this answer in the comment box. Okay, if you are not knowing the answer, just go through the video that I have made on this B2H6 diboron topic of 10 minutes video. can watch it, you will get the answer. Okay, so the next, here we have flame test of alkali metals. So tell me what is the flame test color for these alkali metals. So lithium is there na, so you just remember it as a lithium, little bit remember like a red color, which is lipstick color I can say. Okay, so it will be having red color lithium, and sodium will be having sun color, you can remember, like yellow color you can remember, golden yellow you can remember. Okay, so sodium, so golden yellow here we have. Okay, then next, so barium apple green, so barium is apple green. Okay, so then next, so based on this, see B1, so B1 here we have, so only see by just by knowing one or two options only we can eliminate the other unknown options and we can answer the perfect answer here. See B1 and D2 here we have, D2 here we have, A3, so A3, so I told you now, so lithium something like red, like lipstick color you can remember, I told na, just for trick to remember those words are. Okay, so A3, B1, C4, so C4 means, so C for calcium bricrate. Okay, calcium bricrate. So these are the options here we have. So option 3 is perfect answer for this. Okay, then next, yeah, so now which are the following metals is used for measuring high temperature? Yes, so tell me, so generally we will be seeing mercury in the thermometers, right? So not only mercury, here we can also use at high temperature, we can also use one of the metal from this, so that is what? Gallium. So gallium will be in the liquid state. Okay, so that can also be applicable or used as a like used in the measuring of temperature at high temperature. Okay, so this will be also used instead of mercury, we can also use gallium also. Okay, that is an application of gallium. Okay, yeah, the next here we have, yes, this is also one of the general and important question. A buffer system that helps in maintaining pH of blood between 7.26 to 7.42. Yes, so generally you should get one doubt here. So what is the doubt? See, when we are taking any lemon juice, right? Lemon juice we know it is acidic, right? So whenever we take lemon juice, why the blood pH of blood is pH of our body or the blood or blood fluids are not changing, body fluids is not changing. What is the reason here? What is the reason here? So the reason here is because of the buffer action that is present in our body. So buffer action is because of this carbonic acid and bicarbonate which is present in our body. So this will be maintain the pH value. So what is mean by buffer solution? They will resist the change in pH. Okay, so whenever we are adding small amount of acid or base to this particular substance, so this particular mixture will be present in our body already. So whenever we are taking either acidic solutions or basic solution, so that will be the pH change by addition of this acid or base will be resisted or which will be stopped by this particular mixture like carbonic acid and its conjugate base. Okay, so they will be resisting the pH by buffer solution. So this is what, this is application of common ion effect. Okay, so this is what common ion effect, we have already a video on that, so you can watch it. So that's why pH will be stays in this range only. Okay, so now one more question, does this buffer solution will resist pH all the cases? No, it will applicable only to some extent. Okay, so if you add little amount that can resist, but heavy amount it can't resist as it loses its buffer capacity. Okay, yeah. So here I have a question for you. So tell me the number of monochloro derivatives possible for 2,2 dimethyl butane and 2,3 dimethyl butane are respectively. So how can you do this? So take 2,2 dimethyl butane means write the structure of butane like this 2,2. So this is 2 position, this is also 2 position. Okay, so on this you have to do monochlorination. So you have to do chlorination. This happens in presence of sunlight. Okay, so this is what mechanism, it follows free radical substitution mechanism. Okay, so now see what are the different positions possible for this particular compound, you have to check and you have to do it. Okay, 2,2 again similarly we have 2,3. Okay, 2,3. 2 comma 2, right? So 2 comma 2 means same position you have to put both. So 2 comma 2 means this is what you need to take. Okay, so 2 comma 3 means like this you have to take. Now identify different number of carbon sites here along with the hydrogen. See, this one hydrogen is one type, and here we have these 3 hydrogens are of one type. Okay, these 2 hydrogens are of one type, and this methyl, this methyl, this methyl are of same type. There is no hydrogen over here. So when we replace this hydrogen with chlorine, we will get one kind of product. Similarly here another kind, and similarly by replacing any of these 3 hydrogens, we will get same type of products. So totally 1, 2 and 3. So 3 types of products in this case. And here also, if you place these 2 hydrogens are of same type now, again these 2 hydrogens are also same, and means this 2, all these 4 are of same type. So by replacing any of this hydrogen, we will get one kind of product, and here we have one hydrogen, here we have another hydrogen. By replacing this one or by this one, so we will get one more type of product. So both here 3, here 2. So totally how many products are possible in the first case? It is 3. The second case it is 2. So 3 comma 2 are the option. So that is option number 1. Okay. So now you will be having physics class in continuation to this. Okay. So we'll be wind up with session. So sir will be starting his session. Okay. So thank you for watching. Stay connected with us. Thank you.